Hi everybody, this is Mr. Zarzak, and I'm going to take you through some of the practice that we've done this week with vector addition for a parallelogram, tip-to-tail, and the component method. So here we go. All right, so given these vectors, all right, so I'm just going to do a quick measure and say that this is about 4 centimeters and points up. So I'm just going to redraw that up at 4 centimeters. Okay, this one looks like it's maybe 4, a little over 4. Okay, and it goes up and to the right. Okay, and so I'm going to take this one. It looks like about the same direction here, so it's like that. Oh, probably should have started that in a different spot, but that's okay. All right, and then when I make my copy, okay, the copy that I make of the upward pointing vector also needs to point up, okay? And then when I make the copy of the one that goes up and to the right, I'm just gonna fill in this for the parallelogram, it goes up and to the right. All right, so the corners I care about are this one and this one, because here's where I got the 2 vector tails, and then here's where I have the 2 vector tips. Okay, so that's going to show me how and where to draw my resultant. Okay, you don't have to use a different color, okay, but just so that this shows up, especially because I took it up here into the text, sorry about that. Okay, I'm going to use red just so it shows up. So you can really see this points up and to the right and label it with an R. Okay, moving on to number 2 over here. Okay, so this one points down and this one points to the right. Okay, so I'm going to measure this. This one goes, looks like right about 5 centimeters. Okay, so I'm just going to draw that going down. Okay, and then this one here looks like it's about 6.5. Okay, so I'm going to draw that 6.5. Okay, notice I'm keeping the directions the same. Okay, so now I'm just making copies. All right, so I'm going to have another down one over here that's about 5. Okay, and then I've got this one over here. All right, so this is looks like a square. Okay, which is a parallelogram. Okay, parallelogram, you just need these sides have to be parallel to one another, these sides have to be parallel to one another. Okay, and so there's my 2 tails, there's my 2 tips. So it's going to show me where to draw my resultant. Okay, and I'm going to put that arrowhead on there, make it real obvious, and label it with an R. Okay, and if you think about it, if I add down to the right, well then my resultant should point down and to the right. Okay, number 3 over here, okay, is a little bit tricky because I've got the 3 arrows, so how do I deal with that? Well, I'm going to look at these 2 first. All right, so if I do like a quick measurement here, okay, it looks like this one is about 4 centimeters, and this one is about 2.5. Okay, and so, you know, it's like if I went 4 centimeters this way, and then I came back another 2 centimeters this way, okay, well, you see that there's more downwards than up. Okay, the result of just these 2 here would be an arrow that points down, so this is from where I started to where I finished, and it'll be about 1.5 centimeters long, okay? This red, this is what I'm going to add to this one, all right? This becomes the component that I'm going to add to this one that goes down and to the right. So again, it's about just over 1.5 centimeters, and it points down. Okay, so something like that, okay? And then I'm going to make a copy of it over here too. All right, and then if I copy this one down, if I did it right, I should have a nice parallelogram. Notice I'm keeping the direction the same. Okay, and so here's my 2 corners. So I just take this, find that corner with the 2 vector tips. There's the tails, label it with an R. Okay, so I put these 2 together first, and then I add it to this one. All right, and then the last one on here, so this one is down, and this one is down and to the left. Okay, so let's see. This one is just over 5.5, so I'm just going to redraw it. Just over 5.5. Okay, this one points down and is just over 2. Okay, so notice I got a tip to tail, so I'm going to draw my copy. Again, just over 2. Straight down. Okay, and then here's my parallelogram. Again, I'm keeping this down and to the left because this one's down and to the left, and that's where I get those corners that I care about with the 2 tails and the 2 tips. All right, so then I'm going to take and I'm going to draw that resultant with the arrowhead pointing down to the left and label it with an R. Okay. Let's take a look at the component method. It's a little bit different than parallelogram. Here, parallelogram is for adding vectors. Okay, parallelogram is components, I should say, is about taking and breaking the vector up into pieces so that I can have them in a usable form to add later on. Okay, so we'll get to that a bit later. All right, so this vector here points up and to the right. Okay, so it's going to have 2 components, one that points up and one that points to the right. Okay, and so what I do is I'm going to take and I'm going to draw XY axis from the tail of the vector, like this. Okay, and I'm going to use this corner here because really what I'm going to do is I'm going to encapsulate this with a box. Okay, I'm just going around. Okay, so now why am I doing this? Okay, well again, the vector points up and to the right, so when I draw the components, those components also point up and to the right, and it's the intersections here and here that tell me how long to make those components. Okay, so I'm going to draw an arrow that points up and an arrow that points to the right. Okay, and so those corners tell me exactly how much to the right and how much up. Okay, components are the parts. Okay, these two parts make up this. I'm just going to call this vector A. You can name it whatever you want. Okay, any letter of the alphabet will do. This is the vertical component, so we call that AY. The AY is along this dimension. Okay, and then this is the AX. Okay, so this is the horizontal and vertical components of what I've called vector A. All right, this one over here, okay, I'm going to call this vector B. All right, as you can see, it goes completely sideways. Okay, so really it only has a horizontal component. So really all I need to do is do that and say BX. Okay, so now some schools, some books will ask you to do an extra step where if it's completely in one dimension only, they're going to have you do this. They're going to have you draw a little component and declare that there is no vertical part of this. Okay, so for me that's optional, but some teachers might require it, so that just be aware of that. Okay, this vector, which I've called vector B, is all horizontal BX. Okay, for this one here, this one points up and to the left. Okay, so the components are going to point up and to the left. All right, so what I'm going to do is just real quick, I'm just going to draw that box, okay, around the vector by starting with just sketching a little dashed lines to show like the XY axis. Okay, I'm going to use this corner of the tip of the vector. Okay, that's going to be the other corner of my box. Just like that, okay, and this vector points up and to the left, so the components are going to point up and to the left, all right, and the corner of my box, it tells me exactly how long to make it, not up here, not down here, no, it's got to go right there. Okay, we've got a ruler, okay, so that we can be very precise with this. Okay, and I'm going to call this one vector C, which means that this is CY, and then this would be CX, okay. This one over here, this one points down and to the left. All right, so I'm just going to do the same trick again. Just quick sketch of my two axes. I did the Y one, now let's do the X one. Okay, and then I'm going to take and use the arrow tip as the other corner of the box, just like this. Okay, and using that same arrowhead here, that gets me the other corner of the box. Okay, this vector points down and to the left, so the components of this vector point down, exactly this far down, and exactly this far to the left. I'm just going to call this vector D, making this dx the horizontal component of D, and dy the vertical component of this vector. Okay, so there's component method. All right, so let's just quick review. Okay, so this has got some examples of all of what we just did here. So it says, number one says combine these two using the parallelogram method. All right, so again, back to parallelogram. This vector here points up and to the left, and it looks like it's about 3.5 centimeters long. So I'm going to make a vector that's about 3.5 centimeters long and points up and to the left. This one points down and to the left, and it looks like it's also about 3.5 centimeters long. Okay, so 3.5 centimeters down and to the left. Okay, so notice I've got these lined up tip to tail. All right, so for my parallelogram, I'm just going to make a copy of this vector that points up and to the left over here. Okay, and I'm going to make a copy of this vector that points down and to the left over here. Notice the two corners, there's the two tails, there's the two tips. So when I draw my resultant, okay, my resultant goes almost straight left across. I'm not sure if that's exactly left, but it's pretty close. Okay, and then label it with an R. All right, number two says combine the two vectors using the tip to tail method. Okay, so kind of where we're going with this, the parallelogram is a great way to start because it gives us these corners to look for. Okay, once we kind of get the hang of this, we're going to move towards this tip to tail method. Okay, so it's like 5 3/4, something like that, somewhere between 5 1/2 and 6. Okay, so somewhere between 5 1/2 and 6. Okay, and then this one here points up and to the left and is a little over 3 centimeters long. Okay, so a little over 3 centimeters, and it points that way. Okay, now I could make copies and build a parallelogram, okay, or we can also recognize that if I start here and I end here, okay, well, the resultant is just an arrow that goes from where I start to where I finish, okay? That was one of the things we tried to establish in the vector walk lab. Okay, so there's the resultant. Okay, now that some of us aren't quite ready for that yet, and that's all right if that's the case. If you're more comfortable doing the parallelogram method, you're certainly welcome to do that. In which case, I'm going to take my little 5 3/4 vector and make my copy. It's about that long. Okay, it points down and to the right. Okay, and then this one here points up and to the left. Okay, so if I build a parallelogram, okay, I still get the same result. And there's those 2 corners with the 2 vector tips, and then there's the 2 tails. Okay. Number 3, I'm going to draw the components for this one here. Okay, so again with the components, okay, I'm just going to take and make those axes around the vector. Okay, so I made my y-axis, now I'm making my x-axis. Okay, and then I'm going to complete my box using this corner as my other reference point. All right, and we'll do this side over here. Okay, this vector points down and to the left, so my components point down and to the left. And I use the corner of the box that I've drawn to show exactly how long these arrows need to be. Those arrowheads need to be right at the corner. All right, and let's see, on the last one I left off, it was vector D, so let's make this one vector E, just so it feels special. So this would be EX and EY. All right, this is going to be vector F, and it is all horizontal, so that'd be FX. Okay, and again, not required, at least not by me, but some teachers might, so just in case, Fy is equal to 0. This is completely horizontal. Okay. The back of this has a little challenge for us to do. So it says find the resultant of all these vectors. So this, think like vector walk lab. All right. We're just going to take all these vectors and we're going to add them up tip to tail, and then we're going to draw a resultant start to finish. Okay, the order that you do the addition honestly doesn't really matter. Okay, vector addition is commutative. All right, for my own sanity, I'm just going to number these in the order that I'm going to do them. So I'm going to do 1, 2, 3. I'm going to do 4 and 5. Okay, and the order that you do these doesn't matter. Again, like as long as you keep the directions and the magnitudes the same. Okay, so this one points up and to the left, and it looks like it's just a hair over 4.5 centimeters. Okay, so I'm going to start with this one. Okay, and I'm also going to, in addition to putting the arrowhead on it, I'm also going to put a little spot that says start, just so I can kind of keep track in my own brain. So this was the first one I drew. You don't have to number them, but it's helpful, okay? So then if I look, here's number 2. That one's 5.5 centimeters. Okay, and it's just so ever so slightly down and to the right. So 5.5. The lights just turned off. Hang on one second. Let me move around the room. Okay, lights are back on. Sorry about that, folks. Technical difficulties. Okay, number 3 over here. Okay, goes up and to the right, and looks like it's right about 6 centimeters. Okay, so let's see, it says right about 6 centimeters. All right, and then number 4, I've got down and to the left, and let's see, how long is this one? This one is just over 5.5. Okay, so that looks like about right. 5.5, okay, and this one is just shy of 4 centimeters. Okay, so just shy of 4 centimeters here. Okay, and it points to the right. Okay, so notice that every one of these, tip to tail, tip to tail, tip to tail, tip to tail, this is where I finished. Okay, now the resultant, okay, it's like the sum. Okay, it's like when we do addition, it's this plus this equals. Okay, that equal sign is not the same as the addition sign. Okay, the direction of the resultant is not the same as that with the components. All right, the resultant points from where we started to where we finished. Okay, so just think like, well, if I walk this way, I walk this way, walk this way, walk this way, walk this way, I finish here. I started here and I finished here. The overall result just says if I started and I just went straight there, where would you go? You would go like that. Okay, so almost completely to the right, just maybe just a little bit down. I don't know, I'm pretty close. Okay, so that's it. All right, so I hope you found this helpful. All right, good luck. You got to practice these. You can get good at these. Good luck on your quiz.